Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Diastereomers are stereoisomers that are not mirror images of each other. For a reaction to produce a pair of diastereomers, the product must have two stereocenters or another source of defined stereochemistry, such that the reaction creates a new stereocenter while an existing one is retained, yielding to products that differ in relative configuration at one center but not the other. Moving on to the next step. The starting material has a carbon with two identical methyl groups, geminal dimethyl and a terminal alkene. Addition of HBr would create a new stereocenter, but because the two methyl groups are identical, the carbon bearing them is not a stereocenter. The product would have only one new stereocenter, giving enantiomers, a racemic mixture, not diastereomers. Moving on to the next step. The starting material has an existing stereocenter, carbon bearing H3C on wedge, H on dash, ethyl, and a chain CH to CH to CH is equal to CH2. The terminal alkene is remote, homoallic or further. Addition of HBr to the terminal double bond, Markovnikov, creates a new stereocenter at the internal carbon of the former alkene. Now the molecule has two stereocenters, the original pre-existing one, configuration fixed retained, and the newly formed one. Because the original stereocenter is fixed, the starting material is a single enantiomer. Addition of HBr can give RRRS at the two centers. These are diastereomers. The two possible configurations at the new stereocenter, combined with the fixed original stereocenter, produce a pair of diastereomers. And for the final step, the starting material has an existing stereocenter and a vinyl group directly attached. Under radical conditions, Ruhr, UV, HBr adds anti-Markovnikov. The new stereocenter formed is at the terminal carbon of the vinyl group, now a CH2Br. However, terminal CH2Br carbon has two Hs, it is not a stereocenter, two identical substituents. So only one stereocenter exists in the product, the original one giving only one product, no new stereocenter created, not a pair of diastereomers. Hydroboration oxidation of the vinyl group gives an alcohol at the terminal carbon, anti-Markovnikov, SYN addition. The terminal carbon after hydration becomes CH2O, which again bears two hydrogens and is not a stereocenter. Product has only the original stereocenter, no new stereocenter is generated, so no diastereomers are formed. Conclusion: only option B generates a new stereocenter while retaining a pre-existing fixed stereocenter, resulting in the formation of a pair of diastereomers. Therefore, the correct answer is B. Therefore, the correct answer is option B.